Hello, so in this part I'll be demonstrating how to use the IPs included in the Quartus Prime IP generator and then prototype the design on a FPGA board using switches as an input and then LEDs to visualize the output. So coming to the Quartus Prime application, so this is my Verilog code for the multiplier, and I've also made the IP settings. So if you just look at the IP components, so this is where we have kept the number of bits for the input. So I've kept the data A as 4 bits wide and data B as 4 bits wide too, and then we just click on next. So it's an unsigned, and then we just make the default settings, and then coming to the code part, this is where I've initialized it, and then also initialize the output, and then assigning the first data A to switches 9 to 6, and then data B to switches 3 to 0, and then this is the function call of the IP, and then we'll be writing the result to the LEDs from 7 to 0. So we have 8 LEDs for two 4 bits inputs, and then we are also by default assigning 0 0 to the unused LEDs, which is LED 9 and LED 8. So this is the small SDC file for the clocking, and then this is a test bench file which I've used for the waveform simulation. So once everything is done, we just click on the compilation, and then once the reports are ready, we just fill in the report. So this is what I've got for this particular design. So it has got used of 9 ALMs, 16 ALUTs, 0 BRAMs, 0 DSPs, and 70.67 megahertz frequency. So this was found using the longest propagation delay for the path from switch 8 to switch 8 to LED 4, so which was 14.151 nanoseconds. And then once the compilation is done, we just click on the run simulation, and then we get the simulation output. So this is where we have the simulation output. So if you just see, it's a big set of data. I've just converted the radix to unsigned data, so which is readable. So we'll also verify this on the board. So we just close this Questa. And then coming to the programming part, so we have also verified the pin planner as mentioned in the data sheet or the homework manual, and then we just go to the programming part. So we have to always remember to set up the hardware, which is DE-SoC, and then we just click on the auto detect, and then it detects the connection, and then we add the output SOF file, so which is this. So I've checked on this part, so we just give start. So we can see that this is 100% successful. I'll just be making a video using my phone to show the outputs on the board with various test cases. So hi again. So in this video we'll be looking at the hardware. So we just verify if the outputs are being correct. So let us just take input, say 9 into 5. So 9 would be 1001. So if we remember, these 4 are the data A and these 4 are the data B. These two are not used, And here if we can see the LEDs, so these 8 are what we are going to use. So for 9 it is 1001, so we'll make it 1001, and then for 5 it is 0101, so 0101. So the multiplication is 45 which is the output, and then 45 in binary is again 0 0 1 0 1 1 0 1. So this is for 9 into 5, which is 45. And then coming to the maximum number that can be calculated is 15 into 15. So this is the output for the 15 into 15, which is 111,000,001, which is in decimal 225. And then say probably we make 1111, which is 15 into 0. So we can see all the LEDs are off, so which says that the output is 0. So this was the first part of the homework 3.